What would happen if we turned a dead camera back on, 24 billion kilometers from home? A tiny machine, drifting beyond the sun's breath, points its eye toward everything we've ever been, and clicks. The camera's been off for decades, so why did we shut our only eye forever? What would Voyager 1 see? What would it risk? And what would it mean for whoever finds it after we're gone? Welcome to Void Therapy. Voyager 1 is the farthest human-made object in history, well past the sun's heliopause. Today, it's roughly 24 billion kilometers from Earth, about 160 plus astronomical units, moving at approximately 17 kilometers per second, around 38,000 miles per hour, a speed it stole from gravity assists at Jupiter and Saturn. One radio whisper from us takes about 22.5 hours to reach it, and the reply takes another 22.5 to come back. Out here, there's no sunlight worth basking in, just the faint hiss of charged particles, the weak tug of faraway stars, and a gold record bolted to an aluminum skin, telling anyone who finds it where to find us. From this distance, Earth isn't a stage, it's a pixel. The drama stays the same, we just finally see its size. We turned off the cameras in the early 1990s. After Carl Sagan fought for the Pale Blue Dot, the imaging system was depowered to save watts and to avoid dangerous sun-pointing maneuvers. Okay, so if the cameras are off, could we even turn them back on? And if we did, what would they see? Short answer? Almost certainly not. The Vidicon tubes are ancient. Heaters and support electronics were shut down. Calibration is lost. Even the software pathways to operate imaging are long dormant. Pointing the craft would require precious fuel and careful attitude control. And worse, any mistake that drifts the optics near the sun could blind the instrument or destabilize the spacecraft. NASA retired the cameras because the science trade-off wasn't worth the risk. But let's play the thought experiment straight. What if by some miracle the optics could wake just once? You'd command a slow roll away from the sun, lock on a known star field, and expose for faint, point-like targets. At Voyager's distance, the sun is just a blinding star. The planets are sub-pixel flecks. Even with long exposures, you're mostly catching scattered sunlight and cosmic rays spiking the image. If you're lucky, you stack frames, subtract hot pixels, and maybe tease out a handful of faint planetary glints along a predicted line. Jupiter, Saturn, Uranus, Neptune. Earth as a statistical whisper. It wouldn't be pretty. It would be proof. Yes, we can imagine the shot. But in practice, the camera's gone. Any real attempt would risk a craft that still returns priceless data. So the photo we can take now is mathematical, reconstructed from ephemerides and light curves, not optical. If we can't see home anymore, what can Voyager still tell us? And how is it even still talking? Voyager 1 talks to Earth through the Deep Space Network, giant radio dishes in California, Spain, and Australia. The spacecraft's transmitter is about 20 watts, a refrigerator bulb of power smeared across the void. On Earth, 70-meter and 34-meter antennas integrate that whisper for hours, building up signal from noise until telemetry emerges. Even after a scare in late 2023, garbled telemetry, engineers traced the issue, crafted a patch, and brought it back in 2024. We literally debugged a 1970s spacecraft across interstellar space. That's the kind of sentence that should not exist. And yet, here we are. So what can it still measure? Plasma waves, cosmic rays, magnetic field changes, the texture of interstellar space itself. Not glamorous, but historic. Data from beyond the Sun's realm, where heliospheric weather ends and the Milky Way begins. Voyager can't take portraits anymore, but it's mapping the shoreline of the interstellar ocean. A different kind of camera, one that photographs fields and particles instead of faces. And when the power finally fades, then what? What happens to a human artifact that never stops flying? Voyager's heartbeat is 3 RTGs converting heat from plutonium-238 into electricity. The fuel decays, the wattage falls. For years, Mission Control has been shutting off heaters and non-essential instruments to buy time. Eventually, even the critical systems won't have enough power. The transmitter will fall silent. The timeline is measured in the very near future, years, not decades. When that day comes, the spacecraft will still be out there, coasting. In approximately 300 years, it begins moving through the Oort cloud, a shell of distant comets. In approximately 30,000 years, it exits it. In 40,000 years, it'll pass relatively near another star. Every 225 million years, it completes one orbit around the galaxy. No fuel needed, just momentum and patience. After the last bit flips to 0, Voyager becomes a message in flight. No voice, but not voiceless. A message to who? If someone or something finds it, how would they even know what it is? Bolted to the bus is the Golden Record, a copper phonograph with instructions etched on the cover. There's a diagram of the hydrogen spin-flip transition to define a time unit. A pulsar map gives our location by the unique periods of 14 pulsars, and a sketch shows how to play the record. Stylus position, rotation rate, how to decode the analog images and audio. Inside are 115 images, greetings in 55 languages, nature sounds, and music from Bach to Blind Willie Johnson. It's a time capsule that tries to be humble and honest. Here's what our planet sounds like when it laughs, weeps, sings, and storms. Will anyone ever find it? The galaxy is vast and Voyager is tiny, but time is on its side. If intelligence is scattered like islands, as we argued in our island galaxy theory, then a wandering bottle can beach somewhere eventually. We didn't mail a boast. We mailed a confession. We were here once, and we wanted to be understood. The true value of a last photo wouldn't be resolution. It would be context. The pale blue dot worked because it shrank us to the truth. A modern family portrait wouldn't show cities or continents. It would show fragility, points of light barely clinging to a star. We can simulate the frame. The sun as a bright, saturated dot. Earth, a vanishing spark in glare. Outer giants as faint dust motes near predicted positions. Cosmic rays scratching the emulsion like static on vinyl. You'd need long exposures, careful stacking, and a lot of faith. But the caption would write itself. This is home, from outside the weather of our star. And maybe that's enough. Not for science. JWST, Rubin, Gaia, and every next-gen survey will outclass one more grainy image. But for meaning. The image says, we made a machine that left, but never stopped looking back. In the end, we don't need Voyager's eye to finish the story. The Deep Space Network already turned our planet into a listening civilization. The engineers who coaxed a failing computer back to life after nearly 50 years already showed what humans do under impossible odds. And the record already gave us permission to be small and sincere. If we could switch the camera on, and we can't, it would only confirm what the pale blue dot taught us. The universe is ancient and enormous, and we are, miraculously, both. One day, the telemetry will stop. The last carrier wave will fade into thermal noise. And still, a small craft will keep moving, curve after curve around the galaxy, carrying "Hello" engraved in metal. The picture we really wanted wasn't in the lens. It's in that gesture. If that gold record sparked a question, come see the bigger pattern. The island galaxy theory, a map for a crowded Milky Way that waits to be discovered. Stay curious.